Hi, I'm Paul Henderson at IST Austria. I'm going to talk about this work with Christoph Lampert on object-centric video generation. Recently, there's been increasing interest in generative models of images and videos whose latent space explicitly represents their composition from multiple objects. These models support inference of the structure of a scene, for example, allowing object detection and segmentation. And importantly, they can learn these tasks without supervision, simply by maximizing the likelihood of the observed pixels. This contrasts with typical generative models, GANs and VAEs, which cannot perform inference, they only allow generating new examples. Existing works in this direction model videos as 2D layers or sprites moving over a 2D background. But of course, the world isn't really built out of 2D sprites, but rather out of 3D objects moving around in 3D space, and that motivates our work here. What we do is we model a video as being the view observed by a camera moving through a scene containing several 3D objects and a 3D background. We represent these components either as voxels or textured meshes, and the objects also have 3D position, rotation, and velocity. For the probabilistic model parameterizing this scene structure, we draw a single multivariate Gaussian Z, which will encode the entire content of the scene, including all the object appearances in motion, and then we decode that using several neural networks to get the object parameters and appearances. Once we have these, we differentially render the entire scene starting from the background. We train the model like a VAE. We add an encoder network that predicts the mean and variance of the latent Z explaining a given video, and then train to maximize the elbow, the evidence lower bound. We did experiments on two datasets of synthetic videos. The first shows rooms containing a handful of colored objects. The camera moves around the center of the room while the objects remain static. We first consider decomposing a scene into its constituent objects and inferring their segmentations and depths. First column here is the original frames, then the reconstruction from our model, then the background and foreground components of the reconstruction separately, then the ground truth and predicted instance segmentations, and the ground truth and predicted depth maps. And we emphasize the model hasn't received any supervision for depth or segmentation during training. Our second experiment uses the model to generate new scenes a priori without any input frames. We see it samples coherent scenes with a reasonable distribution of objects and appearances. Our second dataset was constructed using the Carla driving simulator. We created sequences with up to 3 cars driving along a section of road. When decomposing these, we see the reconstruction and foreground-background segmentations are good, though sometimes cars are split into 2 co-moving parts. Finally, here are examples of new sequences sampled a priori from this model. Thank you.